Good morning, children. So, in the last two periods, we studied about finding the limits. So, there we learned two methods. One is factorization, another one is rationalization. So, one is direct substitution. Once you get some known value, you can write the limit value as that value. If it is in any of the indeterminate forms, mostly we have 0 by 0 forms only. So when we have 0 by 0 form, you have to simplify the function and find the limit. You cannot say that the limit is 0 by 0. So one method that we learned is factorization. We found the factors, we found the limit. Another one is rationalization. Now next we have standard limits. The proofs of the standard limits is not necessary. So the form, you should understand the form of these standard limits. Limit extending to a of x to the power n minus a power n by x minus a is equal to n into a to the power. Power is n here. So n into a to the power n minus 1. So what you have to learn in this is, okay, you will be learning the form, but you should see that these x's are same. These are same. These three are same. Power is same. These two are same here. So those things you have to observe. X tending to a. So x minus a here. Here also x and a. Minus. It should be minus only. The power should be n. Then it is n into a to the power n minus 1. Okay, next is limit extending to 0 of sin x by x is 1. So here x should be in radians. If x is in radians, then generally in the problems they will not mention. If it is in degrees, then you should convert it to radians and find the limit. So limit extending to 0 of sin x by x is 1. Here again what you should observe is this is x, and this x should tend to 0. By direct substitution, of course, this is sin 0 by 0 indeterminate. All these are indeterminates only. But these are some standard limits where some higher level of analysis is made and found the limit. And this e is irrational number I explained. E is 1 plus 1 by 1 factorial. All that is not necessary. You just learn e. E is an irrational number like pi. How we have pi. Now, limit extending to 0 of 1 plus x whole power 1 by x. This x should be same. And then this x should tend to 0, extend to 0. These are all extending to zeros only. Here it is extending to a. Now this is the most general one. A power x minus 1 by x is log a to base e. If it is e here, this is in the place of a, if you put e, this becomes log e to base e, which is equal to 1. So like this is just a particular case of this formula only. Now this is log extending to 0 of, limit extending to 0 of log to the base e of 1 plus x by x. Here base need not be mentioned when it is e. When it is something else, we write the base. Generally, log to the base e is denoted by log to the base e. Okay, I'll write here. Log to the base e of x is also written as ln x. When ln of x is written, e is not necessary. It is understood that the base there is e. In some books, this notation is used. Instead of log x to base e, ln of x is written. So it is understood that the base is e. There e need not be mentioned. Now, as I said, x plus a tends to, when x tends to a, x plus a tends to a. Add a on both sides, subtract a on both sides, multiply, divide. Sin x, you can apply same ratio, trigonometric ratio on both sides. Now, x tends to 0 means 2x. When you multiply by 2 on both sides, it is, when you multiply this by 2 on both sides, 2 into 0 is 0 only. Ax also tends to a into 0, 0. X by 2 tends to 0 by 2, that is 0 only, like this. Now here in these standard limits, in the problems we will not be having the same form. It will not be always x only. It will be something else. So suppose you have limit x tending to 0 of sine ax by x like this. So when you have like this, you should convert, when you have a problem like this, you should convert this to this form. This you cannot change. Here you can make these two same. Here you have ax. So here also you should have ax. So multiply and divide by a. Multiply and divide by a. Next, this as x tends to 0, ax also tends to a into 0, 0 only. So now this is in the standard form. Limit x tending to 0 of sine x by x. So this is a number. This number you can write outside like, so you can write this limit as 1 into a, that is a. So you will not always have only x in the problems. You will have something else. So you should convert, you should reduce it to these forms and then find the limits. Like suppose you have limit of e to the power 3x minus 1 by x as x tends to 0. Suppose you have like this. In the place of x you have 3x. So this also you should make 3. So multiply and divide by 3. The value of the function should not change. He has given it like this. So this function only it should be. So if you multiply, you have to divide. Multiply and then divide. Here also multiply by 3. Then 3 into 0, 0. So now this is in the standard form. So this limit is 1. So 1 into 3. So like that you have to reduce these problems to these standard forms. So it will not be always x here in the problems. It may be something else or it may be x itself. In some problems it may be x itself. So in that case you have to reduce it to that form and then find the limits. Now we'll do the exercise C problems. Exercise B problems we'll do in the end. After completing D exercise we'll do. Now we'll do exercise C problems. In this you have some examples. First we'll do those problems. So first problem, limit x tending to 0 of tan x by x. Tan x by x. So if I substitute tan 0 is 0 by 0 form. So you have to simplify. So how to simplify? Write tan x as sin x by cos x. Sin x by cos x into x. Now if you see, sin x by x is our standard form. So you must write like this. X tending to 0 of sin x by x you write separately. And then 1 by cos x you write separately. Then when you take this part, it is the standard limit. And for this you can write the separate limit. You have seen limit x tending to a of f of x into g of x is limit x tending to a of f of x into limit x tending to a of g of x. So this is one function into limit x tending to 0 of 1 by cos x. So like this you split the limit. Now this is the standard limit. You need not mention anything. You can just write into is equal to 1 into. Here you substitute 0. 1 by cos 0. Cos 0 is 1. So 1 into 1, that is 1. Because cos 0 is 1. So like this you have to do the problem. Now next one is limit x tending to 0 of limit x tending to 0 of e to the power x minus 1 by. Okay, we'll do another problem. This will, you can take it as homework. Limit, I'll do this problem. 3 power x. 3 power x minus 1 by root 1 plus x minus 1. Okay. So here again when I substitute 0, this is 3 power 0. 0 minus 3 power 0 is 1. 1 minus 1. 0 by, again this is 1 minus 1. 0 by 0 form. So you have to simplify. How to simplify? Because you have irrational root here. You rationalize. One idea here is rationalize. You cannot directly get a power x minus 1 by x form. So what you do? Rationalize by root of 1 plus x minus 1 into root 1 plus x plus 1 by root 1 plus x plus 1. So it is equal to limit x tending to 0 of, this is 3 power x minus 1 into root 1 plus x plus 1 by, this is a minus b into a plus b. A square, root will go, minus b square is 1 square, 1. So a square is this, root will go and then minus b square. Then 1 and 1 also will get cancelled and it is equal to limit x tending to 0 of 3 power x minus 1 into root of 1 plus x plus 1 by x. Now you cannot directly substitute 0 here because again when you substitute 0, this becomes 0 by 0 form. So only this part is in the standard form. So you have to split the limit and then find the limit. So is equal to 3 power x minus 1 by x is one limit and then another second one into limit x tending to 0 of root 1 plus x plus 1. So this is in the standard form. The limit is log 3 to base e, log a. A here is 3. So log 3 to base e into, this is root of 1 plus 0 plus 1. And that means 2. So the answer is 2 log 3 to base e. So this is the answer. This problem is very, very important. Please learn. All these problems, the problems of this exercise are very, very important. So I can try these problems. Okay, next problem. Next one is, this is again very important. Limit x tending to 0 of, limit x tending to 0 of a power x minus 1 by b power x minus 1. All these problems are compute, find or find the value, compute the value of these limits. Question is, b is greater than 0, b is not equal to 1. These are the problems. So find the value, compute the value, or it can be, evaluate the limits, find the limits, compute the limits, like that. Okay, now when I substitute, it is a power 0 is 1, 1 minus 1, 0 by 0 form only. We have the standard limit as a power x minus 1 by x. So what we do is, we take the same limit and divide both numerator and denominator by x, b power x minus 1 by x. So like this we do. So this point you should remember. Because our standard limit is a power x minus 1 by x, we should divide both numerator and denominator by x and bring it to the standard form. Now write the limit for numerator separately and denominator separately as I explained in those theorems. You can write the new limit for numerator and limit for denominator separately like this. So now the limit for this is, numerator is log to the base, log a to base e, and the limit here is log b to base e. You can leave your answer like this, or you can also write as log a to base b according to the properties of logarithms. So you can write your answer in any form, either this or this. Okay, this problem is very important. Now the next problem is limit x tending to 0. Next, fourth problem, limit x tending to 0 of sine ax by sine bx. Sine bx. So again when I substitute, it is 0 by 0 form only. We have the standard limit as sine theta, sine x by x. Sine x by x should be there. So like how we did here, here also we'll divide the numerator and denominator by ax. First it is ax. Multiply and divide by ax so that this part remains the same. And for denominator, you multiply and divide by bx. Multiply and divide by bx. Now if you see, this is standard limit, this is standard limit. These two are separate. Actually you can cancel this x here. Okay, I'll write in the next step, otherwise it is, so you have multiplied here by ax and bx, multiplied and divided. Now it is limit x tending to 0 of sin ax by ax by sin bx by bx, sin bx by bx into ax by bx separately. Whatever is there in the standard form, that you write separately, and remaining one you simplify. So now x gets cancelled. A by b is a constant number, so I can write a by b outside and then write limit x tending to 0 of sin ax by ax, sin ax by ax by limit x tending to 0 of sin bx by bx. I can write the limit for numerator and denominator separately. Now if you observe, it has to be in the standard form, in complete form. So here you have sin x by x, x tending to 0. Instead of x, you have ax. So multiply on both sides by a. Here on both sides by b. Then you will have ax tends to 0 and then bx tends to 0. Then it is totally in the standard form. And now you can write the limit as 1. So it is equal to a by b into limit of ax tending to 0 of sin ax by ax, sin ax by ax by limit of bx tending to 0 of sin bx by bx, sin bx by bx. Now it is in the standard form. All are in the standard form. X, x, x like that. So it is a by b into 1 by 1, that is a by b. Like this we do the problem. So first understand the procedure. So after observing this, we could see that it is in the indeterminate form. So our standard, we should now think of reducing it to the standard form. You cannot use any factorization or rationalization here. So standard limit. What is the standard limit? Sin x by x. So by x, in the place of x you have ax. So you multiply and divide by x. Denominator also multiply and divide by bx. Now write separately. Remaining part you simplify. Because it is a constant, we took outside. If it is not a constant, you write limit for it again here and find its value. So like this we simplify, take the limit to both numerator and denominator and then find the limit. Okay, next problem. Next, fifth problem. Limit x tending to 0 of, this is again very important for 2 marks. E to the power 3x minus 1 by x. Now our standard limit is e power x minus 1 by x. In the place of x you have 3x. As I explained earlier, you will multiply. 3x tends to 0. 3 into 0 is 0. E to the power 3x minus 1 by, multiply and divide by 3. So that this becomes 3x. So this limit is all equal to 1. So 1 into 3, that is 3. Like this we do the problem. So these are all very important problems for 2 marks. These problems you may get for 4 marks. So once you practice, you can easily do the problems. So as I said, once you are substituting the limits, you should not write limit. Here I am substituting the standard limit. So I should not write LIM like that. Okay, next, 6th problem. This is again very important. Limit x tending to 0 of e power x minus sin x minus 1 by x. Again, when you substitute 0, it is e power 0, 1 minus 1, 0 and sin 0 is 0, 0 by 0 form. So again, you must do something here. What is our standard limit? E power x minus 1 by x. So e power x minus 1 will write together sin x like this, and then we'll divide them separately, and then we'll write the limit also separately, so that both are in the standard form. Minus sin x by x, divide separately. So now it is limit of first function e power x minus 1 by x minus limit of second function sin x by x. So you can see this limit is 1, that limit is also 1, minus 1, 0. So like this we do the problem. So that problem is again very, very important. You can just practice, learn. Okay, next problem. Okay, next problem. Sixth, seventh problem. Limit x minus 1 extending to 1 of log x to base e by x minus 1. Now this problem is a little bit different. Why? Because we have the standard limit as limit extending to 0 of log of 1 plus x by x. This is equal to 1 to the base e. This was our standard limit. But in the place of x, we have 1 plus x, we have x and x minus 1 like this. So what we do is, we'll take x minus 1 as equal to y. Now, this means that x is equal to 1 plus y. Now, x tends to 1 implies x minus 1 tends to 1 minus 1. But what is x minus 1? Y. So, y tends to 0. This we need now. So when we have certain things like this, so one is substitution method, x minus 1, you are taking as y. This is another method. Limit x tending to 1 of, when you keep doing the problems, you can easily learn these methods. Okay, so it is limit of, now I am converting it to y. Y tending to 0 of log to the base e of, what is x? 1 plus y. 1 plus y by y, which is the standard limit. In the place of x, you have y, that's all, is equal to 1 because limit, the standard limit y tending to 0 or x tending to 0, limit x tending to 0. Because of this, you can just write, because limit x tending to 0 of log 1 plus x by x is equal to 1. Okay, next problem. Okay, next, 8th problem. So we completed this problem. These are all example problems which are very, very important. Some more are there, I'll give them as homework. Okay, next problem. Limit x tending to pi by 2. X tending to pi by 2 of cos x by x minus pi by 2. So here again, for when you substitute pi by 2, cos 90 is 0, 0 by 0 form. So I have to do something. So again, see, like how we have x minus 1 here, we have x minus pi by 2. So we'll take x minus pi by 2 as let x minus pi by 2 is equal to y. By taking like this, it can be reduced to the standard form. So that means x minus pi by 2 is equal to y. So what is x? X is equal to pi by 2 plus y. Now as x tends to pi by 2, x minus pi by 2 tends to pi by 2 minus pi by 2. So you are subtracting pi by 2 on both sides. So that means y. X minus pi by 2 is y. So y tends to 0. So now we'll find the limit x tending to pi by 2 of cos x by x minus pi by 2 is equal to limit of y tending to 0 of cos of, what is x now? X is pi by 2 plus y. Pi by 2 plus y by, this is nothing but y. Now what is cos 90 plus theta? Cos 90 plus theta is in second quadrant. In second quadrant, cos is negative. So I should write minus sin y by y as y tends to 0. Now you can see it is in the standard form with minus sign. So I'll write, when I write minus sign outside, it is nothing but the standard limit, sin y by y. So answer is minus 1. So like this we do the problem. So these are the steps. So you are substituting x minus pi by 2 as y. So these ideas you should remember. Then only you can easily solve the problem. So substitution method. So factorization, rationalization, and then here simple substitution to reduce it to the standard form. Next, next problem. 9th problem. This is again very, very important and lengthy also. So limit x tending to 0 of sine of a plus bx minus sine of a minus bx by x. This is the problem. So you know sin a plus b, you will learn this formula in trigonometry. So limit x tending to 0 of sin a cos b. When you write the formula, sin a cos b plus cos a sin b. Cos a sin b. And then this formula, sin a minus b. Sin a minus b is sin a cos b minus cos a sin b. So it is minus of sin a cos b minus cos a sin b. Cos a sin b. B means bx by x. So when you remove the brackets, these two will get cancelled. Sin a cos bx will get cancelled. So it is limit x tending to 0 of 2 times cos a sin bx by x. So here what are you doing? You are writing the formula of sin a plus b formula and then sin a minus b formula. You are writing the formula sin a plus b. Sin a plus b is sin a cos b plus cos a sin b plus cos a sin b. And then sin of a minus b is sin a cos b minus sin a cos b minus cos a sin b. So like this we have the formula. So we are substituting that. A here is small a. A is small a and then b is bx. So we are writing. Now 2 cos a is constant. So we'll write 2 cos a is constant. Limit is over x. So x is the variable. These are constant. So we can write it outside. So limit x tending to 0 of sin bx by x. Now again see, it is not in the standard form. Okay, bx. So multiply and divide by b to bring it to the standard form. So cos a into limit x tending to 0 of multiply and divide by b. So bx and here bx into b. And here also multiply by b. Bx tends to 0. So now all this is in the standard form. Sin x tending to 0 of limit x tending to 0 of sin x by x, which is 1. So it is 2 into cos a into 1 into b. So that is 2b cos a. This is the answer. So like this we do the problem. This problem is again very important. Now we'll do some more problems or we'll write the homework. Now take down this homework. See here you have root 1 plus x minus 1. So you will rationalize. Here you also you can find factors and do. Here sin ax by ax. So multiply and divide by a. Multiply and divide by a. Sin ax by ax is one limit. 1 by cos x is another limit. Like that you split and write. Here again to reduce it to the standard form, multiply and divide by 7. And here you will write sin x minus 1 by x minus 1 into x plus 1. So x minus 1 tends to 0. So you will write limit x tending to 1 of this. So you will write is equal to limit x tending to 1 of sin x minus 1 by x minus 1 into 1 by x minus 1. So into limit x tending to 1 of 1 by x minus 1. So like this you will split. Now this is in the form sin x by x, but x is not same. So you will write x minus 1 tends to 0. For this you will write x minus 1 tends to 0. For this you will write the same limit x tending to 1 only. Because it should be reduced to the standard form of sin x by x as x tends to 0 limit. For this limit only you change this. For the other limit you retain the same limit. So like this you will do. This is 1 and that is 1 by 1 plus 1, 2. 1 into 2, 2. 2 is the answer. 1 by 2, sorry, 1 by 2. 1 into this limit is 1 and this limit is 1 by 2. So 1 by 2, that is 1 by 2. So like this we do the problem. Now this type of problem we already solved with 3 power x. All these are very important. Okay, now here how you do is answer is e cube. So what you do is limit extending to 0 of, you write e cube into e power x minus e cube by x. Take e cube common. Take e cube common. For this answer is 1. Okay, take e cube common. E cube into e power x minus 1 by x. E cube is a constant number. So the limit is e cube you can write outside. So e cube into limit extending to 0 of e power x minus 1 by x, which is equal to 1, standard limit. So the answer is e cube into 1. So like this we do. Now here what you do is sin x. Instead of e power x minus 1 by x, you have sin x. So what you do here also, you will write limit extending to 0 of e to the power sin x minus 1. Okay, I'll do this problem. We have e power sin x minus 1 by x, e power, so we multiplied and divided by x to reduce it to the standard form. In the place of x, we have sin x, so we multiply and divide. Now write in the standard form, limit extending to 0 of e to the power sin x minus 1 by sin x. It should be in the form e power x minus 1 by x like that. And then rest of it you write separately, sin x by x. Now write the limits separately. This limit separate and that limit separate. Limit extending to 0 of e to the power sin x minus 1 by sin x. And for this, you write limit extending to 0 of sin x by x. Now this is in the standard form, but this is not yet in the standard form. You have to still write sin x. Our standard limit is e power x minus 1 by x. What is our standard limit extending to 0 of e to the power x minus 1 by x? In the place of x, we have sin x. So we should write sin x. Sin x also tends to sin 0, that is 0 only. So this is 1 into 1, 1 answer. Like this we do the problem. You can complete the homework. Next period we'll continue with the problem.